Hello everyone, I'm Bingjo. Welcome back to another video. So in this video, we are going into chapter 7 of the IGCSE Math 0580 and we are going into vectors. Alright, so vectors is a whole new kind of concept, but it's actually not too different as compared to, coordinates. So let's just write down what we are going to do today. So vectors, alright, we're going to talk about vectors and how do you denote, all right, a vector. Okay, and then I'm gonna be sharing on how to what is a position vector. All right, what about parallel vectors? Okay, and then after that we're gonna go into simple addition and subtraction of the vectors, and after that we're gonna be go on to scalar multiplication. All right, so vectors is you can imagine you yourself in real life. So let's say right, this is just a simple example, right? Let's say you have you have a destinations, all right? You are currently at A, okay, and you are gonna reach the destination B. All right, so from A you walk all the way to B. All right, we will denote this as A, B with an arrow. All right, so what does this means is you go from A and your destination is B. All right, and the arrow means from A to B. Okay, so in other words, if we are gonna write if we are going back from B to A, all right, then this will be BA. All right, it's just that simple. Okay, it's just your beginning and your destination, and then with the arrow that shows the direction that you are moving. Okay, so this is the number one thing you need to know, which is the directions. And number two, you would need to know something like if I have another place named C. Okay, so if you need to go to C first, then only go to B, then your road will change to something like this. Okay, and then reach C, and then from C go all the way to B. All right, so if we are gonna name all these roads, okay, so this A to C will be AC. All right, so from A you go to C with an arrow that indicates the direction, and then from C to B it will be from C you will go to B with the direction. All right, so as you can see in this diagram, all your all your initial place is at A, and then finally you will reach B. Okay, so we can denote this as, let me push this down a little bit. A to B, all right, will be equals to AC plus CB. All right, so hope you can see how this works. Actually, you can just imagine your where you are now, and then your final destination will be the same, but given on how many different roads, it will be equal to each other. So A to B will be equals to A to C plus C to B. Okay, so you can see how these arrows are showing in this diagram that you will reach B as your final destination. All right, so this is the number one thing that I will mention in this video. And number two, to denote a vector, you can to denote a vector, you can have two ways to denote it. Okay, number one, you can use it as the method I show above. So your beginning and final direction, the final place with an arrow indicating your direction. Okay, number two will be something like let's say A. all right, with a curve, with a wavy thing down here. Why do we need to include this wavy thing? Because if you're gonna see in your textbooks or anything, you will see something like an A, but they will bold the A. All right. So when we are doing in exams, we cannot produce something like a bolded kind of, you can't just use your pencil to, draw the A, which is like, darker or anything. So you must include the wavy length down here. If not, it will be considered as a wrong one. Okay, so it's either this one or this one. All right, they are equivalent to each other, but we can only write this out. Okay, so if we are going to show it up here in this diagram, okay, I'm gonna use another color here. Let's say this one. I would denote A to B as X, all right, with a wavy, and then A to C as Y. All right, it doesn't matter. You denote them, so you will say let Y be A to C and some stuff. All right, and C to B will be Z. Okay, so this equation will now be equivalent to, okay, X will be equals to Y plus Z. All right, it's the same. Okay, so it's depending on how you want to write it out. All right, usually to not make mistake, we usually use this kind of method, but in questions they may sometimes use this also. So they say let the direction of A to B equals to X, then you can use this kind of method too. All right, so this is how we denote a vector. And number two, we will be looking at position vector. Okay, so what is a position vector? Okay, let's just write down here a position vector. Okay, it's a little bit ugly, so let me rewrite this. Position vector. So just as it name, position will mean it's from the origin. All right, so it's at the initial, let's say for everything, so it's at the origin vector. So if we're gonna draw a Cartesian plane, let's say, all right, so we're gonna draw something like this and something like this. Okay, and this is Y and this is X. So your first one here, let's say this is A and this is B. All right, and then this is A to B. All right, position vector is from the origin. All right, so the O is right here. Okay, so you will need to connect from A to B. All right, the position vector is always OA and OB. Okay, so if we are gonna write it down, we will say the position vector, okay, for A is OA and for B is OB. All right, and then if you are going to look at the diagram, this arrow right here from OA to AB is equals to OB, because as you look at the arrows, both of them start from O and will end at B. Therefore, we can produce the relationship saying that OB is equals to OA plus AB. All right, so there's actually one tip that I always like to make sure that the relationship holds is you can see from this part right here. All right, this two is the same. So if we ignore these two, all right, if we ignore these two and take the outer one that are not the same that you can look in the equation, will be equals to O, all right, and B. And the arrows are always to the right, then it's to the right. Therefore, you know that this relationship is correct. All right, so this is a very good tip actually to check your workings all the time about vectors. All right, so position vectors is just the vector from the origin. okay? And you can use this relationship, let's say given that A to B is a vector, and then O to B is another vector given. They want you to look for the position vector of A. Then you can rearrange that saying OA is equals to OB minus AB, okay? So yeah, this is all about the position vector. And next thing I would like to talk about is how does a vector, all right, representing vector in a plane, all right? Okay, maybe I can't use it as a plane. So representing a vector in let's say 2D, okay? The main goal is actually to say that if this is y and this is x, all right? If from the origin we are gonna reach this place right here, which is 3, and this place right here is 4, all right? And we name this as A. So from O to A, we say that is equals to 3 and 4. All right, you can see how we denote a vector which is vertically instead of a coordinate, all right, which is horizontally. So this is the difference between a vector and a coordinate. You must always represent them in a vertical motion, and the top part will be x, the bottom part will be y. So this means that you go 3 units of x to the right and 4 units up. All right, 3 units to the right and 4 units up. Okay, so this is basically the top one, which is technically you can say it's the x, represents left and right, and the bottom one, which is representing y here vertically, represents going up or going down. So if you have a negative 4 here, then it means go down 4 steps. So if you can see from here, this thing right here, we say go 3 units to the right. So we go 1, 2, and 3 units to the right, and then 4 units upwards. So 1, 2, 3, and 4 units. Therefore, you end at A. All right. It's really similar to coordinates, but you need to think it in a way that it's a little bit different. All right, in terms of how do you denote it, how do you represent it in the 2D plane. Okay, so this is all about representing a vector in x, y. Okay, so now I'm gonna introduce to you something called as the parallel vector. Okay, so what is parallel vector? All right, we have parallel lines. Okay, we have a lot of parallel stuff that we've seen before. So if we are gonna write down here, parallel lines have no intersection point, all right, and they have the same gradient, all right. So in vectors, all right, this is just a note. So in vectors, parallel vectors, okay, also kind of have the same gradient, but in vectors we don't usually use the word gradient, and they have no intersection point in between them too, all right. So technically are the same. Okay, if you're gonna draw it on a diagram, all right, this diagram right here, if we're gonna write this O to A, okay, and this is C, let's say B to C, okay, B to C, all right. So if I say that BC is parallel to OA and they are heading towards the same direction, then these two vectors have the relationship of BC is equals to lambda OA. Alright, so this is just a random scalar multiple, alright, where lambda is an scalar unknown, which is lambda is a scalar unknown. Alright, I'm gonna draw the lambda better. Lambda is a scalar unknown. Alright, so you can also denote them as there's really actually very less space down here, so I'm gonna erase this and write it in smaller. BC is equals to lambda OA. Alright, or we can write it as A is equals to let's say if you yeah, it's the same, lambda B. Alright, and we're gonna denote OA is equals to A and BC is equals to B. Alright, so this is how you can denote a vector, and this is the relationship between parallel vectors so that they have a scalar multiple of each other. Okay, so after all these, let's look at what's the next one. We denote a vector, position parallel vector, and it's the addition and subtraction of a vector. Alright, so it's basically the same as the normal addition and subtraction. Alright, addition and subtraction. Okay, they are basically the same as the normal addition and subtraction that you had learned, all right, except you need to add it according to the x component and the y component. All right, so let okay vector x equals to a and b, all right, and vector y be equals to c and d. All right, so as you can see, the top one will be always the x component, all right, x component, and the down and the bottom part will always be the y component. So the x component moves left and right, and the y component moves up and down. So if we're going to add them up, all right, so e.g. number 1, x plus y, all right, if we write like this, we can say it's equals to ab plus c and d. All right, so if you see something like this, it's basically a plus c and b plus d. It's just that simple, a simple addition. All right, and then it goes the same to the subtraction part. So if we have something like eg2, we got x minus the y, then this will be equals to ab minus cd. All right, so as well as you don't mix up, you know, this top left minus the bottom right, then you are good to go. All right, it's just that simple addition and subtraction for vectors. All right, so where are we going to use all this addition and subtraction? When we are given like all these examples right here, when you are given AB and CB, they want you to look for AC, then you will need to use all this addition and subtraction. All right, so yeah, this is all about addition and subtraction, and we're going to move on to scalar. All right, so this is the multiplication. All right, and we are just going to look at a scalar multiple. Okay, and same thing, it's nothing too different. All right, let x equals to ab and y is equals to cx. All right, so all we need to find now is y will be equals to c multiplied with ab. All right, so it works the same as a multiplication, right? So when you have an a outside the multiple, will be equals to ab plus ac. All right, therefore this one will be equals to ca and cb. All right, it's just the same. Okay, it works the same as the bracket multiplication that we have seen all this time. All right, so this is about multiplication, and we know that, and we can denote this saying that it's the same color. All right, and we can say y is parallel to x. All right, because we know from the part where we see a parallel vector have a scalar multiple of the other vector. All right, and this is how you know both of them are parallel, and you can work on a lot of different things in vector. Okay, so next we're gonna talk about magnitude of a vector. All right, so how are we gonna define the magnitude? Is basically like a length in between the two vectors. All right, we can denote them as, let's say I want to look for magnitude of AB. All right, then this will be equals to AB with two modulus at the side. All right, so if AB is equivalent to A, all right, then this will be equals to A with a wavy length modulus at the side. So this is how you denote a magnitude of a vector. And how do you calculate them? All right, so if you recall from the coordinates, we're just going to use one coordinate minus the other coordinate, and then you will use the divide, and then you square and everything. You can check it out somewhere here if you still don't know how to calculate a distance between two coordinates. So now let OA, all right, the position vector of A be A and B, all right, and the position vector of B is equals to C and D, all right. They are just random values. Okay, so the question wants you to calculate what is AB. Okay, so in this situation right here, we first need to calculate AB. All right, number one, AB is equals to AO plus OB. All right, remember the tip that I told you. In this middle part, if they are the same, you can cancel out each other, and the outside one will represent the vector. So AO will basically equals to negative OA plus OB. All right, so from this part right here, okay, this will be equals to CD minus AB. All right, and the length, which is the magnitude, will be basically equals to square root C minus A square plus D minus B square. And it's literally the same as the coordinates that you've seen in the last few videos. All right, so this is how you look for a magnitude, and we are basically half done in this vectors chapter. All right, it's not too hard. So just to recap before I end this long video today. The first thing here, we denoted a vector, all right? So AB, how do you write down a vector? All right, there are two ways, all right? This is usually where the exam will write down as. And I define position vector, which is basically from origin, so OA, OB. And after that, I have talked about parallel vectors, all right? Parallel vectors is like a scalar multiple of the other vector. And then addition, subtraction, and multiplication. All right, addition, subtraction is just the same, multiplication is the same, and last but not least, the magnitude of a vector, it's also the similar to coordinates. All right, so yeah, this marks the end of this video. I hope you guys understand how the concept of vectors work. So yeah, I'm gonna see you guys in the next video where we're gonna learn more interesting stuff like reflection, rotation, and enlargement. So yeah, thank you.